Hello everybody, my name is Joachim Strittmatter. I'm coming from the University of Applied Sciences in Germany, near the Swiss border in the south, and I welcome you to my presentation, Intelligent Implant System for Bone Lengthening. I give you first a background of medical bone elongation, what is this, and show you at least 2 or 3 internal technologies of such implant devices before I show you our shape memory alloy lime lengthening nail in its details, and I give you some ideas of the actual challenges we overcome in the last months. Of course, I sum up at the end. So, bone elongation, this is the dream of all the surgeons about 160 years, and already in 1840 Malghan uh, reported an apparatus for external extension that you can see here in this picture. Others, like here on the bottom, Cotvilla, an Italian surgeon, achieved the leg extension by pulling on a nail driven through the heel bone. So this distraction osteogenesis is also called callus distraction. Others, like Elizarov, a Russian surgeon, they worked with pairs of external rings. As you can see on this little boy here, he has 2 pairs of rings and they are fixed with his upper and his lower leg. And according to the threads, you can here create a bone elongation. Other apparatuses, like on the left, are half-open extension devices by Götz and Schellmann. They used, for example, a hydraulic cylinder where they can push here with a screw hydraulic liquid inside of an implanted half-open nail to create here the bone elongation. So then in 1990, a real basic innovation was done by Augustin Betz and Rainer Baumgart. They had the first totally implanted nail with a propulsion motor, and he was activated with high frequency energy transport. So, bone elongation can be achieved by external methods. You can create own bone material and bridge defects after bone section, and you can achieve daily elongations of approximately 1 millimeter. They are also suitable for the correction of wrong positions. The internal systems, they do the same job, but they cannot be used for bone corrections. But if you have a tube that is sufficiently big, you can place the whole implant system inside the bone. So, how is this done on the market? This is the Albizia nail from Guichet. He uses ratchet mechanisms, and you have to turn here the upper leg about 20 degrees to the left and to the right 15 times to create an extension of 1 millimeter per day. This nail is also nicknamed twist and shout nail, but the patients said they feel no pain. An improvement was done by the intramedullary skeletal kinetic distractor. He has 2 such ratchet mechanisms, and therefore a twisting of only 9 degrees is sufficient to create the nail lengthening. The monitoring is done by this device, where you can look what is the position of the magnet inside and calculate approximately what is the achieved elongation. Our shape memory alloy lime lengthening nail, of course, is based on a system that uses a shape memory element. I don't go in details for shape memory element, only one sentence is, with this fascinated functional material, you can create a phase change only by heating and cooling, and this gives you enough force for using it as an actuator. What is the principle of our device? Here you can see that we have the shape memory element in the form of a tube. So inside of the whole system there is a heat element. Outside we have a bias spring. And the whole system is fixed here in slider 1 and slider 2, and I hope you can see that the sliders as well as here the outer tube has a sawtooth profile. So if I heat the whole system, what will be done? The shape memory element contracts when it overcomes the phase change temperature, and because slider 2 is blocked because of the sawtooth profile, slider 1 makes one shift movement in this direction. If I interrupt the heating, the bias spring that is stressed further by this contraction pushes the whole system apart, and now slider 1 blocks and slider 2 makes one step further. So it's moving like an inchworm or like a caterpillar. This is a sketch of our nail. At the moment, I only want to focus that we have separated the position of the shape memory element and the bias spring in order to have more space. Therefore, we have bigger cross sections and we can achieve higher forces. 3 such small prototypes, here you can see the receiver coils, they were tested in a cadaver trial at the University Hospital in Münster in Germany. The function could be confirmed, but as we detected some weaknesses, we started a re-engineering. First of all, the new connection technology. The higher forces now, it was not able to crimp only the shape memory tube on the pin or on the shaft of the other metal parts. Now we use here position number 3, so-called heat shrinkable metal rings. They also are based on a shape memory principle. They have a one-way effect. Let's say if you push it slightly above it, they are wider, and if I heat it in a cabinet, then they shrink and they press this shape memory element with the other pieces of our nail. We did a lot of tests where we worked upon the inner surface of our nickel titanium tubes with electro polishings and with some grinding processes. Also the other parts, these are only dummies. We worked with different geometries and surface finishing, and then we put all together with a joining device in our hydraulic press, and in the thermal cabinet we activated the shrinking process. Afterwards, with our universal tensile test, we tear it apart. Here you can see on this diagram the maximal forces over the elongation, and all of our dummies, they reach reliable more than 7,000 Newton. This means we have reliable connections of our nickel titanium tube with the other parts of the nail by using heat shrinkable metal rings. We also worked upon our switch. It's not at the end of our nail like in former times. We placed it now exactly under these catches with the sawtooth profile that move here inside of this outer tube, and when it moves, they move a little bit down, and therefore they activate this new switch mechanism on these pins and detect a signal. This electronic signal is one part of our new control technology. We have a resonance circuit consisting of capacitor, receiver coil and heating resistor, and in this parallel resonance circuit it's possible to oscillate with the heating element, and we can generate the phase shift. With this phase shift we can detect really the movement of our parts, so we can monitor the whole elongation via phase shift detection. With this I sum up. The advantages of the intramedullary systems is the maintaining of the intramedullary tube. We have a reduced risk of infections, and we have good results in terms of the cosmetic result. Additional advantage when you use our small is that you can monitor the whole elongation process for the first time. And thanks to the high power density of the shape memory elements, it's possible to miniaturize the whole system. So we have a linear movement, simple mechanical principle, and only a small number of moving parts. And therefore it's possible not only to create a better system, but also a cheaper one. With this, I'm at the end of my speech. I thank you very much for your attention.